Now that faces that you have collected will be now used as an algorithm. We will build a k nearest neighbor algorithm, and using that k nearest neighbor neural network, sorry, k nearest neighbor, we will be uh, trying to create a model, and we will try to fit in for face recognition. So on Monday we have discussed about the KNN, that is K nearest neighbor. Today we'll continue following that, and I will finish the rest of the things. So here we go. You can observe here that we're having our K nearest neighbor waiting, and let's try to build our model. So let's start with our new, and also we need to have our snipper link. How many of you finished the sample collection part? How many of you have finished the sample collection? Participants, could you please answer if you have collected the 200, 300 face images that I asked on the last meet? Okay, I'll proceed with the next part. Enough asked you all. If, I can't see anybody responding even. So it's better to proceed with the next topic. Those who have completed, you please finish this particular project. And let's go ahead with our next topic, which will be related to our uh, creating a model with KNN and finishing this particular task. So let's go ahead and let's try to particularly our face expression part is over. So we'll go ahead with our sorry face sample data collection is over. Now we will start working on uh, creating a model. So in order to create a model, we'll be using recognition using KNN or K nearest neighbor. This is a machine learning algorithm. So let's try to particularly build the model from the scratch. And while we'll be creating it from the scratch, we will be able to understand the maths behind it, which is nothing but its distance formulas, which on top of it this is built or created. So yeah, let's go ahead with that. Import numpy np, import cv2, import os. First of all, I need the distance formula. If you remember that to find or to recognize if a sample is nearest to class 0 label or class 1 label, distance will be the criteria, and number of nearest neighbor will be also the criteria. That how many number of such samples are there in the support of this new data sample. In order to find out the nearest neighbors, I need to know about the distances, and for that I will be using Euclidean distance formula, which is a normal distance formula that we learned. Euclidean distance formula: def distance v1 v2 returned np dot square root of v1 minus v2, take the square on it, and dot sum function. So np dot sq, one more square bracket will be needed. Sorry, one more curly bracket is needed. No, that's okay. This is my Euclidean distance formula. This will be point number one. This will be point number two. Differences between them, and we take the square and we take the sum of. Along with that, I need to create a nearest neighbor which will take the sample data and the testing data. Testing data will be our own image. So def k nearest neighbor will take your training data, which will be all your available images that you have collected. Testing data and number of nearest neighbor, I am setting it as 5. You can take any odd number, 7, 9, 10, sorry, 9, 11, any number you can take. The distances that will be calculated by distance formula will be stored as a list for I in range function. It will start from 0 and it will go all the way till the number of samples. This loop will run from 0th image to last image, and that's why a collection was required. Now let's get the label. Ix equals to train I. Only the last part contains the, so this is your features of the images, or you can say training images. That's why the last element is ignored. If you remember, we talked about this minus y thing. Minus y, minus 1 means last value will not get included. Let's talk about the label. Label will take the last value. So this will be given by iy. Let's take the distance, which will be given by distance formula. Test value ix. Then we go with my distance dot append, and in that we will have the distance and the respective label. Remember that these are the features of the faces that we have collected. So if we will try to understand it, what exactly it means is that we have multiple faces features which will be there, right? These will be multiple faces features. Imagine these circles are the different faces of the same person, whose features will be scattered like this. This is for person number 1, this is for person number 2. Now let's say a new face is getting detected. So in order to recognize if it is person number 1 or person number 2, we need to be dependent on only one factor, and that is how nearest they are to the available features. Are they nearest to person number 1, or are they nearest to person number 2? So these are your train data. In this coding part, wherever I'm using train, I mean these are my training data, and this is my test data, or you can say test sample. Now for the test sample, we will basically use the web camera again, and through the web camera it will able to take the images, and according to that it will try to give you the prediction. Okay. Now we have selected the distances, and also we have stored that whether it belongs to label 1 or label 2 or label 3 or label 4. So first of all, we have to calculate the distances between all the images to the test data. That is what we have done. Now we need to select those k distances, k number of distances which are nearest. Now, in order to have the nearest, we need to apply that sorted function which we have used earlier as well. This particular part, sorted one, but not as a reverse, but it has to be in an ascending order. We'll start with k x of, and we can save it as dk or something. Sort based on distance and get nearest 5 nearest, k equals to 5, right? K equals to 5 nearest, or nearest features. From the features we will able to know which are the labels. So this particular data that we have collected here, this dist part, this will go here, and this particular distances will be sorted in an ascending order, and then we will select only the top 5 shortest nearest distances. After that we will retrieve the label from this, retrieve only labels from this. Labels will be given by np.array. Select all the value except and yeah, this is how we can particularly focus on selecting our values. So we have retrieved the labels. That's it. This is what my k nearest neighbor should return. This is what our output will be also there. Now, in order to get the frequencies of each label, we have to basically take the unique value np.unique. This will return me the counts. You can also apply value counts as well, but this will return you the frequency of each labels, which is important. Now let's find the maximum frequency out of that. That will be my predicted value. np.argmax, argument max is used as I discussed in our basic discussion. np.argmax returns index position of the maximum value. Now from here what we will do is we will simply go to my return. This is the return type function. We will take here my output label 0, and attached to it will be the indexes. So these 3 lines are basically returning me the predicted value of the label. But remember, this will not work if you have not collected the data. Now after doing this, we will move to our next part, which will be, let's take the test data. As I said, the test data will be nothing but it will be your final sample video that will be taken. So cv2 dot video capture face underscore cascade. We got here with my cascade classifier. Let's provide my OpenCV cascade frontal face. Okay, now here we go. We go here by my face underscore cascade. Let's read my image. Image data set path where all my images are stored. My images collection are stored here, which is your dataset path. So I'll copy the same. And make sure that your path is when given correctly. Wherever your NPY file is created, that will be your image path. And wherever your har cascade files are present, that will be given here. And yeah, take care of the forward slashes and all everything. Like here in the end, we have got forward slash. This is the location where my images are stored. You also verify yourself that where your images are available, and according to that it will work or behave. Now let's move ahead to the next part. With the dataset path coming in, we'll pick here my face underscore data, which will be given by. Similarly, we have got labels, which will be again given by a list. We have the class id, which will be initialized as 0, and names will be stored as a dictionary. So basically, we have to extract the dataset path, and from there we need to pick my values. Talking about my test data sample, let us go to my test data part, which will be actually given by the same video detection example that we took. Not the I one, but only the face part. So I'll copy it, but I'll remove those parts which are not required. Like we don't need this thing. We will write it with true. Return frame capture dot read has to go with vid. It is my variable where my video is stored. Then frame resize if needed. Otherwise, you can just leave it. Next, convert the frame into the grayscale. Detect multiscale. I will keep it as 1.3. Again, this has to change according to your environment. It's coming up. Face underscore cascade is not found. What's the name here? Face underscore cascade is there. Okay, face underscore cascade. Detect multiscale we got here. Then for face in faces, multiple faces will be there. Your face will return you four things. In fact, this particular part is inspired from this whole section. So it will return me four things: x, y, height, and width and height. This is given by face. Let's add the offset value. So get the face ROI is offset equals to 5. Face selection will be equals to, sorry, face section, not selection, will be equals to frame y minus offset colon y plus h plus offset x minus offset colon x plus w plus face section. Let's resize the face cv2 dot resize, and we'll provide here face underscore selection. It has to be resized to the original image. Remember that we are preparing this all for the test data. Okay, my test data will look like this. Face section will be reshaped to 100 cross 100. This whole section is your testing images. So that's why we need to select the face from the real time, and we have to prepare it exactly in the shape of my training data. Remember, my face training data was like this, so it has to be also following the same. It had got offset of 5 pixel extra, and it has reshaped itself into 100 cross 100 shape. Now we need to do the main part, that is prediction. In order to make the prediction, we have to call out here out equals to, let's call the function KNN, which will take your train set, data set, and your face selection image, face section image, and then we need to draw the rectangle around the frame. You can choose any color. This is for the color coordinates, and this is for drawing the rectangle around the selected face. Along with that, we need to also add cv2 dot put text around the original frame image. Names will be basically take the label value number, and according to that your name will be at a specific index position. So this is what I wanted to print on the frame, that is my original image, and my position will be x minus y minus 10. This is basically the position where the text will appear. Text will, it should have a format as well. So we are having different formats. I'll go with a very simple font format here, font underscore Hershey complex, or in fact we can take simplex as well. Text width or text size 1, text color. You can take any color here. I'll go with 25:0 to 255. Text width, or you can say the font size of the text. cv2.line underscore AA. These are all the details that we need to put up the text. And remember, the text will come up here in the form of name. And name is what we will add additionally. We have not added the name part. That's it. This part is over. You can see that, okay, eyes are not required, so we can eliminate the eye section. This whole part will go. Okay, we have got rectangle we have created. Then put text is also done. cv2.im show. We have to write this with faces. Hit key 1, and we need to compare if q is pressed or not. So this is all about for the trend. Sorry, this is for your testing of prediction, which will basically use the images that we have collected on Monday. Cap will be replaced by with. That's a variable name. Okay. Now this is all done here. Dataset preparation for all input samples. For fx in os.list dir dataset underscore path. Now basically what we are trying to do, we are trying to extract the name. In order to do that, we are extracting all the files which are present in the given input path, and we are looking to get only those images which starts with npy. Oh, sorry, ends with npy. If my file name ends with npy file, then only we will consider those files, and then from there we will extract the things like names and all. This part is basically for data preparation part. In this case, we are loading all the data set, and we are getting the targets as well. We are also incrementing the target id with the number of type of images we will be storing in my location. Let's say in my face data set right now there is only one value, there is amit.npy file, so id with generated will be only 0. If there will be 5 files, so they will be given 0, 1, 2, 3, 4, 5 in terms of that your id will be given. But to how does it will extract the name, in that the purpose of the file is very important. See one line where we are trying to see only those files which ends with npy. So even if there will be a file which does not belong to npy, that particular file will not be part of this, because we are making sure that with whatever the file name we have read, os.listdir basically returns you all the input files which are available to us, and from there we will take only those files which ends with .npy file, and then from there we will see like how many such files are there. According to that, it will be given with the class IDs, and to get the labels we will be basically reading the file, and from the file it will basically take the value accordingly. This was about the data preparation. Now let's pick my face underscore dataset. Should be concatenate face underscore data with x is equals to 0. Pick my face underscore labels, which will be equals to np dot concatenate, and to that we will add labels along the rows. X is equals to 0 is along the rows. We have to reshape this as well. Basically, row will become column and column will become row. Because we have added here something like -1, comma 1. Remember that it will prepare the labels like this 0, 1, 2, and like that. It will work. Let's pick my train set. Concatenate. Concatenate is basically merging the two arrays. That's what this is used for. Like we did concatenation of list, similar to that. Face underscore tables that we will add here x is equals to 1. Just print this shape if this comes out to be the training set shape or not. This should not return you empty value. Face labels are also done. You can take the face labels shape to know that how many faces are there, that faces data sets which are there. We can have one label, two label, three label accordingly. Okay, this looks fine to me. Doesn't seem to be having any error. So basically, you can collect multiple faces here. If you have not collected, you can collect it now and generate near about, let's say, 100, 200 such faces with different angles and different shapes. And once you are done collecting them, you can start with the next code, which was discussed today, which will be using the concept of your k nearest neighbor in order to make your predictions. Are we labeling each and every image with a .npy file? NPY file is getting created through your samples. That is, your sample file will be generating .npy file, which was created earlier. Now we are reading those files and we are labeling like 0, 1, 2, 3, 4 according to the number of images that has been collected. -1 means it will not include the last value. Last value is let's see what is going on here. Train is your data set, no? Train is your data set.
So is it to train the ith last value till last value, sir?
There is some problem. Let me sort out. I think there is. Yeah, there was no problem. I think the camera responded a little late. So basically, you can simply run this program after you have spent time on data collection. All you have to make sure is that you give the correct path. There is no other error. If you are committing any other error, that is only due to your.
So basically, output of this whole exercise will be in my video camera webcam. My image will
The
be
code is
identified with my
shared.
name.
You can try them
Hello,
for face
am I
recognition.
audible?
This was the project
Hello,
of face recognition.
hello,
And to do that one, we are using the k nearest neighbor KNN
hello.
face recognition. Hello.
Yes. Can you see my screen?
Oh, can you show me your file first? You were saying file part first. Show me the file.
This file. It was saved that day, and today again I updated it. So yeah.
Yeah, but you can generate more images. This is, I think, it is not
Yeah.
even
So
100.
actually, it should also the previous code sample collection is whenever it is run, it is saving file only with one name. So 300 times the same program to be run. Is it
I didn't understood. 300.
easily like we have to first calculate the distance, then KNN. All these steps, like I'm finding it difficult. Like when you are doing indexing, array kind of indexing, I don't know if everybody is finding
This
the
will come with the this will come through the experience only because the code is from the scratch. So that's okay. You can break them into multiple parts and print each and everything whenever you get a time. You will see that this is not that difficult. It is just indexing that we are doing in this. And for everything I have written, like what exactly this line means,
yes.
what
Yeah.
exactly this line means. So comments are already there. Like we discussed about np.argmax. So argmax returns me the label of the maximum frequency. So basically what is going on in this? In the first step, we created a function of distance, which will basically take the distances between the 2 points, which will be the train point and the test point. Train and test will be passed here, and the number of nearest neighbor is getting passed here as a parameter. Then we are collecting all the distances. To collect the distances, we have taken a list. Then we have read all the data. To read the data, we have to take the shape 0. Shape 0 is what? Length of the data, whatever the number of images we have collected. Now it will go through all the images, and through the images it will take all the features here and all the labels here. Once it has taken it, we will start calculating the distances, and we will start appending them into this list. And then to that list, we will simply sort them into an ascending order. Why we are doing it in an ascending order? So that we can find the top 5 shortest distances, and that is what that is from where we will extract the label.
Hmm. Got it. But
Then
your choice of selecting indexes over lambda functions or inline functions, then using numpy arrays is like very quick decision you are taking. So difficult. Like sometimes you are doing it unique. You are using sorted, then unique, then this. So I found it
these are the
difficult.
function. Obviously, it
Yeah.
will be difficult for you to understand because this is the first time you are learning. But over the period of time, it will become easy. It can't be
Okay.
done in a. This is one of the lengthiest program that we have to discuss. And why it is lengthy? Because it you need to understand it. This has got 3 part. First part is your KNN algorithm. Second part is preparation of the data, and third part is your preparation of the test data set. That is why this
Yes.
program is lengthy. Now we are done with. It is impossible what you are asking, that a single file will have multiple faces, and then how to detect and label them. Whenever you label or classify, you should have them stored them separately. The train data will be always stored separately. If it is not stored, that means it will never able to predict accurately. And that is coming up to this particular part. KNN is, where is KNN? This is the KNN. Now I will stop using this particular thing. I will start using the Jupyter notebooks. And in the Jupyter notebook, I will basically be focusing on creating the deep learning part. So we are about to start with that. We have here my train data shape. What is a particular mean here? What is train data? Train data is the data that we have collected here. Okay, let's see here what we are passing into this. This is the train, right? What we have passed. To my train, we have passed train set. What is train set? This is my train set. Now my train set includes 2 things: face data set and the labels. What is my label? Label is an array, separate array. Face data set is a separate array. So we are having basically the collection of what is train set. Train set is array of all faces and their labels. Labels are present in the end, and the faces are present in the first part. So how we will not include the labels? By not including the last value. How to not to include the last value? -1. So what is labels here? Labels is this particular value, which is what? Let's say what is labels? Let's go ahead. Labels is basically labels dot append and target. Okay. So it means labels is a list. What type of list value are stored in this target value? What is target here? Target here is the class ID multiplied by the ends of the shape, ones of the shape. So basically it will be value 0, 1, 2, 3, 4, like that. Now this 0 will be passed to the name which we have did here. When name 0 will be passed, that means it will take first file. Name 1, second file. Name 3, third file. Name fourth file. And according to that, name will appear in the text. So whenever we build a machine learning algorithm or deep learning algorithm, remember your labels will be always in a number form, because we are dealing with the numerical calculations, and numerical calculation does not understand textual part. So please remember that machine learning will only take the numbers. That's what it is. Array of all the faces and their labels, and labels will be basically a list with 0, 1, 2, 3, 4, 5, and so on. And this will be faces will be your faces. Array of all faces. Remember all faces why we are passing, because we have to calculate the distances among all the value, and then only we will make frequency of the labels, and from the frequency of the labels we will find which particular label is most frequent. That's why we have 2 3 parts included in here. Now I think it is pretty much clear to your question. What is the meaning of -1?
So fx then square bracket then all colon -4 means last 4 will be excluded from the fx. If fx dot end, so after that names class id equal to fx.
This is file. This is file. Fx is what? Fx is in list osdir. This is file. No, it's written right here. This is to list the files. Fx is file name. Fx will read all files name from location one by one. Fx is file.
No, fx file all colon -4. That is what does it mean actually?
What is
File.
this fx here? Fx means what? Fx means file. I am not including the last 4 line. That is what it means. And for that better good, I have written here. No, what is written? That adding named ID from the file sample. Look at here in the file. What is in the file?
So
In
basically
the
to
file
exclude
we
the
have got.
extension.
Yeah, obviously that's what we are doing. We are excluding the last 4, and what is last 4? It is .npy file. So last .npy extension will be eliminated, and we will get all the names. And from the variable name also you can apply the logic. No, what is name? Name is should be something which is related to the name of the files, like Amit or the person's name. From there it is also included that what it will be storing.